is the apparent, the power, okay? And P is the active power. And Q is for reactive power, okay? So the unit for apparent power is the VA, and active power is watt, and reactive power is what? VAR. And the S is apparent power. We can describe for the polar form, the polar form, and then the rectangular form. The polar form, the amplitude, the S sub APP, and theta. Okay, that is what? S sub APP cosine theta plus J S sub APP sine theta. Why?
VA is voltage parent. Voltage parent reactive. VAR, I think.
Yeah. Oh, I'm sorry. VAR, something like this, right? Yeah. So, oh, I'm sorry about it. So that one is maybe R sub V sub RMS multiply I sub RMS and cosine theta plus J V sub RMS I sub RMS times sine theta. So that means that was the S sub APP. That is also plus J and Q. So the P is like this one here. P is the formula right there. And the Q, this one, like this one here, okay? That is the Q reactive power, okay? So V RMS multiply I sub RMS, the multiply sine theta is RMS times the I sub the RMS, that is the cosine theta. So the triangular, the power, that is the angle, that is the P, and that is the Q, okay? That is what? S sub APP. That's very important, okay? Not S. What is the S sub APP? Like this one. What is the theta? Like this one, okay? All right. So sometimes it depends on the value for Q and P, that is upward Q, sometimes the backward of Q minus Q. And sometimes the P is the right side, sometimes horizontal, D is the left side. Okay. All right. So, and also the last week, we learned about the power factor, okay? The power factor. The power factor is sometimes PF. The unit is the percentage. I think you can see that the page, the 9 from my printout. What?
The bottom line there, the top.
Just right this one?
Yeah.
Oh, okay. Okay, thank you. So the power factor. So the power factor is the formula P over S. The P is watt, S, V, A. Okay? So the power factor is calculated by active power divided apparent power. Active power divided apparent power. Okay? That is the power factor. Okay? So all right. So for today, oh, And then that is the maybe also for from the triangular power, that is the cosine theta, right? From here, we can find the trigonometrics, like the cosine theta is the power factor, okay? So that means that we can calculate it a lot of maybe approach by giving, the given, the value from the questions, okay? All right, any questions? Okay. So you can go the page, the 11 for my printout. So today we have important something. All right, so the power factor is measured with AC circuit, include sometime R sub L. I'm gonna do writing for you. Power factor will be able to be measured from AC circuit. Sometimes register the inductor, sometimes the resistor and capacitor. Okay, so it depends. Okay, oops, I'm sorry. All right, so all right, so the case one, so the capacitivity load, okay, like this one here. So for this case, for example, like this one, no, maybe no, just maybe AC circuit that consists of the resistor and the inductor. That is the end. Yeah.
Okay.
Yeah. Resistor and inductor, maybe, or resistor and capacitor. For example, the pressman for this case right there, C, right? This is R. That is the AC source. Plus minus, plus minus, plus minus. For this case, the power factor is said to be leading. Why? Because the power factor is recognized between the voltage and current relationship, especially the I current lead V voltage. Okay. I mean, for the future, we will deal with several the sample exam. But now I'm gonna just my definition is here. So maybe R and capacitor for this case, power factor should be say leading. Why? Because for this case, I lead voltage. Okay. All right. So for this case, we can draw the triangular. This is P. The P what? The active power. But here, the Q, the downward. The Q is the downward. What is the Q? The Q is reactive power. Reactive power. So like this one here, that is S sub APP, that is theta. Okay. Okay. One more time. if you see the R and C, the components in the A circuit, the power factor should be, say, leading, because I lead voltage, and you cannot draw, the power triangular, the Q, the downward, okay? I might be able to maybe ask you from the quiz or from the exam. Maybe I'm gonna show you that circuit. What is the power factor, leading and or lagging? You have to say leading. The question 2, why? Because I lead V by some degree. It depends on the value of each element. The question 3, please draw the power triangle. This is the power triangle. So you have to draw some value active power, reactive power, or downward, and theta, some value, VA, kind of, okay? So how about the inductive load? For this case, yeah, the power factor is said to be lagging. Why? Because I current is lagging voltage. Okay. And then that was the inductivity right there. Yeah. And then that was the P, and that was the Q, that was the theta. Oh, sorry about that. Just right there. That is the S, the P, VAR, S, VA. So can you see that right there? That was upward Q. Why? Because the power factor is lagging. So how can we know about this one? So maybe inductive, the road case means like this one. Oops, I'm sorry. That was circuit R L. Sometime like this one, just only the R, but maybe it depends. Okay. All right. Okay. Any questions? Okay, so now maybe I'm gonna give you the sample exam. Okay, but 10 minutes break. I mean, I can give you the 10 minutes for the sample exam, like this one. All right, that is exam 1 here for today. Okay, like this one. R X of L, 40 ohm here. R is the 30 ohm. V sub S 120, V sub RMS the 0. Okay, so the question is, what is the P? Okay, and what is the Q? And what is S? VA, a polar form. Okay, and what is the power factor? And that was the leading or lagging. Why? Okay. maybe I'm gonna give it about 10 minutes. Okay, just try. I like this one. Can you see that right there? I sub t. I sub t is the total current. I sub t is total current. Okay. So do you remember in the last semester when you learn about the DC circuit, if we know the I t is I sub r, I sub x sub l, same, means I sub t is equal to I sub r is equal to maybe I sub x sub l. Oops, that was really slow. What's going on? Oops, okay. So I sub r and I sub x sub l. All right. Why? Because that is the AC series circuit. AC series circuit. So to find I sub t, we're gonna using the Ohm's law. How? V sub s divided the G sub t. That is for total current here. So the V sub s, like this one, right? And what is the G sub t? The G sub t from the circuit is right there, R 30 ohm, okay? And the X sub L 40J. Why? Because that is the inductor for the reactor. The inductor J, the capacitor minus J, or this is Y, 40J. Okay. So here, G sub T is 30 plus 40J, and V sub S 120 0 degree here. So I wanted to make a conversion. Skip the conversions. Finally, the answer 2.4 M and minus 53.13 degree here. Okay, so that is the answer for I sub t. Now the P is we can be the express as I sub t square the multiply the R. Okay. Right. So the I sub t square is what? The 2.4 square multiply the R. The R is the 30 ohm here. Multiply. Okay. Yeah. Okay. Any question? So that was the answer is 170.8 watts. Okay. And
You also use voltage times I.
oh yeah. VI the cosine theta.
Oh, you got to do cosine theta.
Yeah. V sub RMS, I sub RMS, you know what I mean?
Yeah.
Same, right? Yeah, same. So for this case, V sub RMS, I sub RMS, V sub RMS 120 multiply I sub RMS like this one 2.4 multiply the cosine minus 53.13 degree here. Similar, yeah.
Minus 53. 13.
Yeah. Okay. So, and then the reactive power, I sub x sub L times the x sub L. Okay. Okay. But some students has mistake. What mistake? Some students, they wanted to calculate it for reactive power, I squared times R. No. The only register for the reactive power, the inductor or capacitor component still with the Q, because it depends on the capacitor. It depends maybe on the capacitor. That is the what inductor and capacitor. Why? Because what do you remember? P plus JQ. The J is complex number indicator. Okay. I'm gonna do writing for you. Okay. P plus JQ. J, the complex number, the indicator. So it depends on the maybe inductor, maybe or capacitor. The Q value upward, sometime downward. Okay. So the Q value, to go back to the question 2, the Q value I square x sub L times the x sub L. So that was 2.4 times x sub L, 40 ohm here. Okay. So that is the answer for 230, the point for VAR. Okay. That is the answer for reactive power. Okay. All right. So what is for the S? The S is P plus JQ at sub APP theta. Okay. So the P is, 170.8 watt. The plus J, the Q is what? 230.4. So maybe after you make a conversions for the polar form, you can find finally the theta and the amplitude for S sub APP for the apparent power, like this one here. Okay. So the answer is 288 VA 53.13. 30.13. Why? Because that is the inductor from the circuit, right? That's right here. So the inductor, I'm writing for you. Oops, I'm sorry. The inductor, that was the P, that's right there. And then that was the Q, the upward for the inductor case, like this one. So this is why the theta should be the positive. Okay, go back to the inductivity, the cases like this one. Okay, so this is why the theta should be plus the positive. Okay. And then so the next question is what is the power factor? The power factor is P over S. P over S. Okay. Or the cosine theta. The theta is what? Like this one here. So the cosine 53.13 degree is the power factor. Okay. So that was 0.6. Hey, professor, can you use the formula, the P over S? Yes. It's up to you. But the theta plugged in of the cosine theta, that is more faster. Okay. I know that it's a little bit confusing, but we have the future lab. We will deal with that one. Okay. All right. So any questions so far? That was the power factor. All right. So that power factor leading or lagging? Leading or lagging? They should be lagging. Yep. Why? Because the circuit consists of the L. You have maybe any L maybe in the circuit, we have to say that is the lagging. Okay.
So there's an L in there lagging.
Right. Yeah. So the last question is we have to draw the power triangle, just like this one. The upward. Y, that is the inductor, and theta is 53.13, and that was what as of APP, and that is P, the watt. Okay, this is the VAR. So
negative 53.
No, the negative is for capacitor.
Okay. Yeah.
Right. So the P is from the answer we have already calculated 172 watts, and reactive power we have already calculated before is 230 VAR. Okay. And then S sub APP we have already calculated. Go back to here. 288. Okay. 288 VA. Okay. It's right there. Maybe as sub maybe APP, that is the also by using concept of trigonometric P square of the Q square, that is the S sub APP. Okay. All right. Okay. Any questions?